Welcome back. This is lesson 6C. If you've been following along with us in lesson 6A and 6B, we drew a 3D canoe using the loft tool, and then we made the seats using some standard extrusion tools, but some types of references to surfaces that we hadn't used before. To finish off our little boat, we need to make a rail around the top and some grab handles at the front and the rear. To do this, once again, we're going to use the default planes as our starting point. This is why it's so important that when we draw things, we draw them in a way that makes sense in terms of the planes that we're given.
Because of how we positioned the canoe when we first drew it, the canoe is bisected by the front plane front to back. Of course, we're going to make use of a bisecting plane once again, just like we did for the seat rails, but this time in the other direction. To do this, we will rotate the canoe so that we are looking at one end of it. Then, we'll fit it into our window here and use our view positioning cube to get it aligned perfectly. Like in lesson 6B, we're going to select the bisecting plane and then activate the section view to temporarily eliminate half of the canoe from our view, so we can see the cross section at the plane we're drawing on. Our goal is to build a rail on each side. Since they both have to run along at different edges, we'll build them one at a time. Since the canoe is symmetrical about the planes, we could, if we wanted to, make one rail and then mirror it about the plane that bisects the canoe longitudinally. We're going to use the sweep tool for the first time for these rails, and then we'll have a full lesson on the sweep tool in lesson 7. So, let's select our front plane to draw on and then start a sketch. We'll use a center rectangle for our shape. We can use the point at the center of it to align it with the edge of the shell. You'll see that the rail will be off-center by half of the thickness of the canoe shell, but for our purposes, that shouldn't be a problem. We want this rail to encapsulate the top of this shell, so a bit further on, we'll use a relation between the center point of the rectangle and one of the edges in the shell. This will snap our rectangle into a position where the top of the shell gets buried in it. Like with the seat rail mounting bosses, for visual purposes, we can let SOLIDWORKS just mash these two features together. But if we wanted to actually use this drawing to create parts we could really assemble, we'd need to incorporate a slot in the bottom of the rail for the sides of the shell to go into.
We'll assume we're using the same stock wood as the seat rails, so we'll dimension our rail to 30 millimeters wide and 20 millimeters tall once again. Now we're going to apply what's called a pierce relation. To do this, we select the center point of the rectangle and, while holding Control, we then also select the edge that runs along the outside of the canoe. In the Properties box that opens, we click on Pierce. This will snap the center point of the rectangle coincident to the outer edge, but it also creates a special property that allows the point to follow the line in the pierce relationship when it is being swept or lofted. We'll say yes to the pierce relation.
It doesn't look like we have much of anything going on here, does it? When we turn off our section view, we just got this little rectangle sitting there at the midpoint of one side of our canoe. Let's exit Sketch. We now reselect the sketch we just made, and up in our Features toolbar, let's activate Swept Boss Base. We can now see that the sketch is highlighted because it was already selected. And this is our profile. We'll see it listed in the box with the profile icon beside it, which is the little circle. The next box is our path. We haven't selected one yet, so we're going to zoom in so we can make sure that the same outside edge that we'd set the pierce relation to. There we go. So we now have a top rail that runs along the path until it gets to the next node, but it only goes in one direction. In our Extruded Boss Base toolbox, if we want a profile to run in two different directions, we activate and choose both directions 1 and direction 2. In our Sweep toolbox, there's no direction 1 and 2, but there are little icons showing the sweep going to the left of the contour in both directions and to the right. We'll select the bidirectional icon and our rail now runs to the next node at the front and back of our canoe. Of course, we don't want it to be of the material it defaults to, so we'll make sure that the features aren't merged, and then we'll make it the same brown that we made our seat rails. As always, when we make a new feature, we'll name it Left Side Rail. Now we'll repeat the process for the other side rail. Or we can simply mirror this rail about the right plane. Of course, if we mirror it and anything at all was misaligned, the rail will wind up in the wrong spot.
You can see that starts to make it look a little more like a canoe and less just like an empty shell. We still have nothing on the top of the shell at the front or back yet. Because the shell was created in separate lofts, the rail stops where the one loft ends and the other begins. But this isn't necessarily a bad thing, because it gives us the freedom to do something different with the bow and stern of the canoe. Generally, these areas aren't covered by a rail. They're covered by a plate that has a hole in it to make the canoe easy to grab and pull with a human hand. We could try to draw it on the top plane, and then project it onto the top surface of the canoe shell using a wrap, emboss command, but we'd be blocked from selecting the surface, and we'd get an error message reminding us that the wrap tool only works on planar, cylindrical, conical, extruded, or revolved surfaces. If we tried to use a sweep like we did for the rails, we'll find that something about how the ends of the canoe were drawn prevents us from selecting the top edge as a path. So, we're going to use a standard extrusion to draw this part, but first we'll need to create a plane to draw it on. We'll create that plane by selecting 3 points. If we use the node at the ends of the main shell and then the very tip of the end shell, we'll get a plane that runs very close to the surface at the top of the portion of the shell we still need to cap.
We'll draw a profile for our bow on this plane. Then we'll cut a hole for a grab handle, and we'll put fillets on it to make it comfortable to use. Everything looks good, so let's set direction 1 to 10 millimeters up and direction 2 to 10 millimeters down. That looks good. Let's accept it. So now we've got a front part for our rail. We're going to make sure that it's not merged and then set the appearance to the same brown that we used for the rest of the rail. Of course, we'll name it. Now we'll draw on the top surface of this end plate and put a slot in it that fits a hand. Once done, we'll put fillets on the top and bottom of the hole to make it comfortable to grab, and then we'll rename and recolor the hole and the fillets.
So now at least one end of the canoe looks like a canoe. Let's select the extrusion, cut, and fillet we made this end cap from and mirror them about the front plane. Since this plane bisects our symmetrical canoe, they will wind up perfectly copied to the other end of the canoe. That's it for our basic canoe. We could add a portaging rail in the middle, but the technique to do this would be just a repeat of things we've already done in this lesson, so we won't bother. We hope that you enjoyed this lesson and learned how to use the CAD tools to make less boxy shapes that can be made with the extrusion and cut tools we used in earlier lessons. See you in lesson 7, where we'll look at the sweep tool in a little bit more detail.